All right, so now we want to talk about other area problems. The integral, our ability to find a definite integral, or at least to get a calculator to find it for us, gives us the ability to find certain areas. Remember, the integral from a to b of some function gives you the total area under the curve and above the x-axis minus area above the curve below the x-axis. So if this area was 4, and this area was 5, and this area was 3, then the integral from a to b of f of x would be 4 counts as positive, 5 counts as positive, 3 counts as negative. The simple version is the function is above the x-axis and you get the area below the curve. But there's a weirdness that if the function goes negative, then that part of the area counts as negative, which makes sense when you think about it from some points of views, but for most geometrical applications, you don't really want to ever think about any area as negative. The thing to clarify is that the integral does the weird thing that counts some area as negative. The word area hasn't changed. So for example, if I said find the total area between the x-axis and y equals x, between x equals -1 and x equals 2. Y equals x looks like this. If I go out to -1 and +2, then we're talking about this area. And the thing to understand is find the total area. The word area counts stuff as positive. This wording counts everything as positive. So just computing the integral from -1 to 2 of x will give the wrong answer. In this case, the total area is, I guess I can do this one by hand. This is a triangle whose height is 1 and base is 1. It's half of a 1 by 1 square, so this area is a half. This area is half of a 2 by 2 square, would have area of 4, so this area is 2. So the total area is 2.5, but the integral from -1 to 2 of x dx is going to be this counts as positive and this counts as negative, so it'll be 2 minus a half is 1.5. And this section is mostly about clarifying the difference between these two answers. I shouldn't put a box around the whole thing, because this is the answer to the question that they asked. And it's different from the thing that just giving the integral will be. When we're talking about area, the fact that the integral counts area below the x-axis as negative is usually a difficulty we need to accommodate, or something. It's a thing we have to work around. The second deal is often the area we want to work out isn't between the x-axis and the y-axis. So let's say find the area bounded by y equals x squared and y equals 4. First off, there's this question, what does bounded by mean? Or I guess the area of the region bounded by y equals x squared and y equals 4. A shape is bounded means you can draw a circle around it. Like this is the literal definition of bounded, is it doesn't go off to infinity in any direction. There is some circle big enough to contain it. When I think about the graphs of y equals x squared and y equals 4, they cut the world into a bunch of pieces. How many pieces? We got 1 piece, 2 pieces, 3 pieces. All of this is all connected. Like 4 pieces, 5 pieces. To say find the area of the region bounded by is to take all of those regions which are bounded. Most of these regions go out to infinity in some direction or another. This one goes out in lots of directions. This one is the only region I could draw a circle around, so that is the only region bounded by. If there were multiple, it would be the total area of all of those multiple things. This is what we mean by a region bounded by some curves, is draw those curves and see if any of those regions that you've cut the world into are finite. All of those are the region bounded by the curves. So in our case, so that's this area. Y equals 4, y equals x squared. When we are doing this, we care about, like, to figure out, oh, I didn't shade it. This is the area we want. To do this thing, I'm going to be setting up an integrals, and I need the integrals from where to where. So I care about where are these points, which means we're going to care about where do those curves intersect. To find out where curves intersect, I set the equations for those curves equal to each other. When does x squared equals 4? That's x equals plus or minus 2. Are the places where these intersect. -2, +2. We can get the y values also. These are, when I plug 2 into either of these functions, I'll get 4. When I plug -2, I'll also get 4 in. We usually don't need the y values, but maybe they'll help us get a gooder picture. But we need the -2 and 2 because whatever we integrate, we're probably going to be integrating from -2 to 2. Sometimes, because I'm in a context where we're going to be using our calculator to do the integral, I will sometimes be giving you problems where you need to use a calculator to get digits on what are those intersection points. We'll do one like that in a second, but here it's easy to find the values -2 and 2 by hand. So now we need to know, what do we want to integrate? There's kind of 2 ways at this, or they're basically the same way. One is to notice, or I guess they both come from noticing, that the area between the 2 curves I can rewrite as what's the area below the top curve minus what's the area below the bottom curve. The thing the integral can give us is what's the area between the curve and the x-axis. If I want the area between 2 curves, it's pretty easy to write that as the difference between, here's the area between the curve and the x-axis, here's the area between the other curve and the x-axis. This one's a rectangle. I can do the area of that by hand. How do I pause it? I lost my pause button. Sorry. In this case, the area is a rectangle. I can do the area by hand, but let's pretend it's something harder where maybe we can't do that. In this case, it'll be the integral from -2 to 2 of 4, which is here the top function. And this one is the integral from -2 to 2 of x squared, which was the bottom function. Look, this is my region, this is my top function, this is my bottom function. And yeah, the area we want is the integral from -2 to 2 of the top function minus the integral from -2 to 2 of the bottom function. And it is a fact, we haven't justified this at all, but it turns out to be true, that you can combine these into 2 integrals. If the bounds of integration between 2 functions are the same, you can combine them into one integral of top minus bottom. You might not want to compute the integral that way because the picture your calculator will draw when you compute it is wacky.